Hi everyone, so I promised I give you an explanation of example 1. So here it is, example 1. So we want to find T, tension in AB, which is this part, the tension in BC, this part, and the tension in CD. Then we want to find what's H, which is the horizontal distance of B from A. So first things first, we draw the free body diagram. And as you can see here, we put these two reaction forces here. But for this part, we put TCD. So we can find out TCD right away. Now in the class, I mistakenly put theta here. So what we should have done was not put theta, but see that actually we already know the slope. So if I draw TCD here, I can resolve this into two forces. But what's the slope? Look at here. This is 1.5 and this is 2 meters. So one of your friends pointed that out to me. Thanks for that. Sometimes we really miss out the small things actually. So thanks for pointing that out. So if I draw this 2 and 1.5, I can actually change this into 4 and 3, and we have a Pythagoras triangle here. So the slope here is like so. Now we don't actually need to calculate this angle here. We can just use the ratio of the slopes here. Now, what we need to do is, like I said before, we take up the summation of moments at A equals 0, where a counterclockwise direction is positive. And from here, we can see that B acts in a clockwise motion, so that gives us a negative value. So negative 3, which is 3 kilonewtons for B, multiplied by this distance here, so that's 2. Then we have C, which also acts in the same direction as B, so that's -8. And the distance is 4. So far so good, right? Okay, now we go on to D. So like I said, D has 2 components. So what are these components? So this one is TCD, not sine and cosine anymore, because we're dealing with ratios. So to get TCD, you get the component which lines up with TCD, which is 4 here. You put 4 on top, and you take the hypotenuse, which is 5, and you put it at the bottom, and you put 4 over 5. And that's how much of the component TCD acts in this direction. Now for this direction, we take the component which is the same direction as this, which is 3. So we put 3 on top, TCD, 3 on top, divided by the hypotenuse, 5. So that's how you resolve those into their component TCD, into their component forces with the ratio as you can see here. So let's continue on with this equation here. So we've done this, now let's do this one. This is TCD 4 over 5, this is TCD 3 over 5. So TCD acts in a counterclockwise motion, so that's positive. So positive, oops, I should be using black. So that's plus TCD 4 over 5. Then we multiply by this distance here, which is 4 plus 1.5, that's 5.5. Then we take TCD as well, which also rotates in a counterclockwise motion. So plus TCD 3 over 5 multiplied by this distance here. You always want to take the distance at a right angle here. So this distance is what you want, right? You don't take this distance. You take this distance because this is what rotates it like this. So that's 2 meters, and it's equal to 0. Now, multiplying all these out, get -6 minus 32 plus 4.4 TCD plus with 1.2 TCD equals to 0. 38 plus 5.6 TCD equals to 0, and TCD goes to 38 divided by 5.6, which gives us 6.786 kilonewtons. So we have just found TCD. Okay, now we can move on to finding BC and AC. So we'll move on to point C. So point C has this TCD here, and this, this TCD here, and this TCB in this direction, and don't forget the 8 kilonewton force that pulls it downwards. So from here, what we'll do, resolve the forces in their respective directions. So the sum of forces in the x direction is 0, where the right is positive. Now, minus TCB, in this case, we need to use the angle theta because we don't have the ratio of the triangle. So we need to use the angle right there. So TCB, and remember, if TCB, if you want to find this component, it is, if the angle is here, it's TCB cosine, cos sebelah, right next to it, cos sebelah here. So TCB cosine theta. I'm not going to write the CB here because it's going to be a bit tedious. So I'll just leave it at theta, plus with TCD. Now we have the ratio, so we don't need to use cosine. We can just write TCD. Now remember, which component, which line are we taking? 3, because it's in the same direction as this one. So 3 on top, then we put the hypotenuse on the bottom. This equals to 0. Okay, now let's work this out. Since TCD is how much? 6.786. 6.786 kilonewtons. So minus TCB cosine theta plus 6.786, 3 over 5 equals to 0. TCB cosine theta plus, once you work this out, comes up to 4.072 equals to 0. Now, rearranging this, we get TCB equals 4.072 over cosine theta. So we leave it like this, and then we move on to the y direction. So the summation of forces in the y direction equals to 0, where up is positive. So we have TCB going to this direction, which is sine, because cosine is for this, cos sebelah, so sine will be the other side. So we have TCB, positive TCB because it goes up, TCB sine theta. Then we have TCD in this component, so you will take 4 because it's in the same direction as this one, 4 divided by 5. So plus TCD 4 over 5. And then the last one is, is 8 kilonewtons. I tried to scroll the TV screen there. Okay, so this equals to 0. Now let's work this out again, but remember, TCB is this, so we can substitute it right into here. So 4.072 over cosine theta multiplied by sine theta plus TCD. Oh wait, remember TCD, we already know what that is 6.786, remember from here, okay, multiplied by 4 over 5 minus 8 equals to 0. So I can actually combine sine theta and cosine theta into one factor. So 4.072 sine theta over cosine theta plus with 2.571 equals to 0. Okay, so this all becomes 2.571 equals to 0. Now sine theta over cosine theta is equal to tangent theta. So 4.072 tangent of theta plus 2.571 equals to 0. So rearranging, we can get theta as 32.25 degrees, or simply 32.3 degrees. Now we take this value and then we substitute back into this. We get 4.072 divided by the cosine of 32.3 degrees. This gives us 4.82 kilonewtons. So this is TCB. Great so far, right? So we only have one more to find, which is AB. So let's take a look at B. So B has this component here, and since I already know the value, I'll just write it straight away here. And this angle, since I know that this is C, since I know that this angle is 32.3, then it follows that this angle is also 32.3 degrees. So again, we'll start with the horizontal direction. F of x equals to 0, where going to the right is positive. This we get minus TBA, since TBA is going that way. And remember, cos sebelah. Cos sebelah will be next to the angle, cosine of theta. Again, I'm not going to write BA to save time. And then 4.815 goes in this direction, which is positive, so plus 4.815 cos sebelah, right? It's an easy way to remember. And that's all. It's equals to 0. Now, rearranging and calculating it, TBA cosine of theta minus, this all becomes 4.07. I won't skip a step. You might get confused if I do. So minus 4.07 is equals to 0, this equals 0. So we rearrange this to get TBA equals 4.07 divided by cosine of theta. Then we do the vertical component. F of y was 0, where the top going up is positive. Now looking back at our figure here, TBA sine of theta plus, oh, we don't need a plus, TBA sine of theta minus 4.815 sine of 32.3 degrees minus 3 equals 0. Then we substitute this into TBA. So this here goes right here, 4.07 over cosine theta, sine theta. And this all becomes, let's see, minus 5.57 equals to 0. And of course, sine theta and cosine theta will become tangent of theta. Minus 5.57 equals 0. Tangent of theta is equal to 1.2 369, and your data will become 53.8 degrees. Okay, substitute this back into this formula. TBA equals 4.07 divided by the cosine 53.8. You will get 6.84 kilonewtons. So congratulations, we found the 3 tension values that we want. We found CD, BC and AB, but don't forget, we also need to find the value of H. So we need to find the value of H here, but notice that, I'll zoom out a bit for this. Notice that AB, I need to zoom out more. Notice that AB, this distance is 2, of course. This distance is H, but then remember we calculated this value here. The angle is 53.8. So the tangent of this value is rise over run, which is H divided by 2. So solving, we found H is equal to 2.74. So I'll upload these notes in the Microsoft Teams for your reference, and also for examples number 2 and 3. And if you have any questions, feel free to send me a private message on Microsoft Teams, or you can send me an email. I recommend sending through Microsoft Teams because I think it's easier that way rather than sending an email. So I hope you all understood this whole thing, and looking forward to seeing you in the next class. All right, thanks.